Hello everybody, we are into week 3 of this particular course. So, in this particular lecture we shall have a quick recap of what we discussed in week 2, and then we shall discuss 5 variable Karnaugh map and entered variable map for SOP simplification and POS simplification will also be discussed. Very quickly, in week 2 we have seen that logic circuit operation can be represented by a equivalent symbol, a Boolean expression like if it is a AND circuit, then y is equal to a b, truth table, the different combinations of the input generating a specific output, and also through timing diagram. So, different kind of timing input combinations of the digital waveform, high and low will come, and accordingly output will be generated. And we also saw that NAND and NOR can be considered for universal logic circuit as a universal gate for different kind of logic circuit generation. Then we looked into Boolean algebra, the basic premise of Huntington postulates and certain theorems, and then we found that using that we can simplify Boolean expressions and can have more efficient realization of digital logic circuits. And given a Boolean function, we can convert it to a particular logic circuit. For each operation, we have a specific logic gate associated, and we just implement one by one, and then the final circuit is obtained. We also saw that canonical SOP, sum of product representation using min term, and canonical product of sum representation using max term can be realized easily by two level circuits. Two level circuits for SOP was AND and OR. Alternately, NAND circuit can also be used, and for POS the basic circuit is OR and AND, direct from the equation we can get, and then also we found that with little bit of manipulation we can realize that by NOR circuit as well. We also looked at the concept of negative logic and dual circuit and found its use, and finally, we ended last week with a discussion on Karnaugh map based simplification. Okay. So, any truth table, how it can be mapped into a Karnaugh map, and then that Karnaugh map can be used for simplifying SOP and POS representation, and also we looked at don't care input and how that can be used for minimizing the circuit. So, in today's class, before discussing entered variable map, let us see if the number of variables under consideration is 5. Okay. We have discussed Karnaugh map up to 4. So, now we are looking at this Karnaugh map for 5 variable representation. Okay. So, now we are in a bit difficulty, because for 5 variable representation up to 4 variable we had a 2 dimensional plane, we had considered 0 0 0 1 1 1 1 0 on one side like this, and this side also 0 0 0 1 1 1 1 and 1 0, and then we had considered logical adjacency even at the edges and so on and so forth. But when it becomes 5 variable, so number of these cells, this number of the square boxes is 2 to the power 5. Okay. So, that is 32. So, now this 32, the finding logical adjacency, this is a bit difficult, and one perhaps require a 3D visualization to understand how this adjacency is established. So, what we show here is a reflection map based 5 variable simplification. So, in the reflection map based, this side side remains what it was earlier for 4 variable, and the other side here we are representing the remaining 3 variable, okay, out of 5 variable. So, C, D, E 3 variables are there. So, C is 0 0, C, D is 0 0 0 for this particular column, the first column. Okay. Next one is 0 0 1 and so on, then next one is 0 1 1, and after that 0 1 0. And this vertical line over here, okay, the vertical line over here. So, this represents the axis against which a reflection is done. Okay. For example, so this 0 1 0, its reflection against this means this 0 becomes 1. okay, for the value C. 0 1 1, its reflection is 1 1 1. Reflection means 0 and 1, that is just getting reflected, I mean the 1 1 remaining the same, okay. 0 and 1 is. So, between then this cell 3 and 7 there is a adjacency, because only one variable is changing, that is C. Similarly, this is 0 0 1 and this is 1 0 1. So, this 1 and 5 is also adjacent. So, wherever you see a reflection along about this axis, okay, and the corresponding positions are logically adjacent. So, this is the way we have to visualize this one. Okay. So, there can be another method, popular method, which is called overlay method, where here this one, this is 0 0 0, the first cell over here is 0 0 0 0 0 0, all values are 0. So, in this case the C value will be only changing to 1. So, this will be 0 0 1 0 0, this particular position, this particular square box. So, as if this, I mean both are just lying one above the another, okay, and the adjacency is drawn across the overlaid or vertical direction. So, in this present example, the present method, it is about the reflection about a particular axis. In the overlay method, just one above another. So, we shall discuss only one of this method, which is the reflection map based method. The other one is similar, just the adjacency pass needs to be considered through just one lying above the another, and from that. So, because of this the numbering, that is min term numbering in the specific cell is what you see over here, 0 1 2 3. Okay. A is the most significant bit here, and E is the least significant in terms of the binary representation that we are showing, and then this is 4 5 6 7, okay, 8 9 8 9 10 11, then this is 12 13 14 15, then there is a jump because there is a 1 0. So, 16 17 17 18 19, and this is 20 21 22 23. Is it fine? Okay. So, this is the way these min terms, the 32 min terms will be represented here, okay. And the positions here is showing that D is remaining 1 over this 4 cells, okay, these 4 columns, okay. That means total 4 into 4 16. A is remaining 1 for these 2 rows, okay, these 2 rows, this row and this row. So, 2 into 8 16. So, that is the thing that you see for other variables. Okay. So, we take up one example to help us understand how this 5 variable Karnaugh map can be used for simplification of Boolean expression. So, in this example we are taking up min terms 2, 6, 9, 11, 13, 15, 18, 19, 22, 23, 25, 27, 29 and 31. Okay. So, what is the first job? Since we already know from the previous discussion that how these min terms are placed. So, accordingly wherever those min terms are there, we are placing the ones. Okay. So, 2 0 0 0 0 1 0. So, 2 is a min term. So, 1 is placed here. Okay. Next is 6. So, 0 0 1 1 0. So, 6 is over here, you can see 6 is over here. So, corresponding 1 is placed. So, accordingly all the min terms the specific positions the ones are placed in the 5 variable Karnaugh map. Okay. Now, after that we need to do the grouping, and in doing the grouping we need to consider logical adjacency, and logical adjacency in the neighborhood region which is easily clearly visible, okay, as well as the one that is coming through the reflection, okay, the one that we just discussed. So, the one that we can see, which is a group of 4, we can see over here. Here is a group of 4, this, okay, there is a group of 4. Now, about this vertical axis, you can see this, they are just reflection of one another. So, they remain, they are logically adjacent. So, this 4 and this 4, that is total 8, they form one particular group, and that will contribute to one product term. Okay. And in this particular group, which variable is remaining constant? You can see B is remaining constant, okay. And the other variable that is remaining constant over here is, you see, E, again here E and E. So, this is also remaining constant. So, for these 8 mean terms, B and E are remaining constant. So, the corresponding product term that will get generated is PE. Is it clear? Next, we look at remaining, I mean all the ones we need to cover through the largest sized, which is size is integer power of 2 number of groups. Okay. So, next is this one and this one. Let us consider this one. So, this 2 1 and the other 2 1, they are, because of the reflection, they two are neighbor and can be grouped. Again, we have already seen before that this at the edge and this is at these two are at the edge, they are also neighbor. So, these 1, this 2 1 and this 2 1, they can also be considered as one group, and in that particular group we can see what are remaining constant. B is remaining constant with a value 0, that will contribute to B prime, and D is remaining constant with 1, this is 1 in both the places, and E is remaining constant with 0. So, B prime D E prime is the corresponding product term. Okay. Now, what is left? So, these 1, 2, 3, 4 and the other 4 plus 4, 8 are covered. So, what is left is this one and this one. These two ones are not yet covered. Now, to cover that, okay, we can see that we can, I mean one thing that is clearly visible is that a group like this can be formed, okay, with logically adjacent 4 ones, and this particular generates a term A, B prime and D is remaining constant. So, this product term will get generated. The other thing which is not very apparent, but again if we consider the reflection, we can see that these two are logically adjacent, easily understood, okay. But again it is against this particular axis, they are, one is reflection of the other, okay. So, that way also this group of 2, this group of 2, they are logically adjacent. So, accordingly a group of 4 can also be formed, which is of similar size of the as the previous one what we considered over here, and this group of 4, if we just put them together, right. So, this is these 4 members together, you can see that A, D and E, these 3 are remaining constant over here. So, this one and this one can be covered by either of these two terms. Okay. So, accordingly you have got B E, right, B prime D prime E and A prime A B prime D or A D E, one of these two as representation of the minimized expression of this 5 variable function, okay, through Karnaugh map. Is it clear? So, similar thing we can do for POS representation as well. Now, what we look at, we shall come back to this problem little later, what we understand by entered variable map, before which we shall discuss what is entered variable. Okay. So, entered variable is, if you look at a truth table of 3 variable as you see here A, B, C and the corresponding function output is y. So, a truth table is generated out of it, okay, where the output is written as a function of one of the variable, which is the entered variable. Okay. So, in this case we look at 2 examples for the same truth table. In one case we see C as the entered variable. Okay. So, when we see C as the entered variable, we look at how the output function changes with respect to change in C when other variables remain constant. So, other variables here are A and B. So, A and B remaining constant with the value say 0 0. So, what are the 2 positions in the truth table? These 2 positions are in the truth table 0 0 0 0 for A and B, and C is changing from 0 to 1 over these 2 rows. Okay. So, we pair it in this manner. So, this is for A B 0 1, this pair is for A B 1 0 and this pair is for A B 1 1. Okay. So, for each of these cases, we get one entry into the truth table where the variable is entered. Okay. The variable is entered. Now, we consider at this point that for this particular pair, how the output is changing with respect to C. We see that output is remaining constant 0, irrespective of change in C input variable, output is not changing. Okay. So, y is equal to 0 in this case. In this case, what is happening? If C is 0, y is 1. If C is 1, y is equal to 0. Okay. So, that means it is just complement, y is output is complement of C. So, y is equal to C prime for cases where a b is 0 1, and next case again we see that output is not changing, remaining value remaining constant with the value 0. So, y is equal to 0 and this is y is equal to 1. So, accordingly this truth table is formed where a variable you see C prime has entered. Okay. So, if such is the case, in another place C can be there or another place, I mean depending on the truth table. So, there is a possibility of a variable entering into the mapped enter variable entered truth table. Okay. So, instead of C, if we had a different variable, say for example, A entering into the truth table. Okay. So, A is the entered variable. In that case, what would have been the way the pair would have been formed. So, in this case, since A is entering, so B and C remaining constant, that is what we have to see. So, B and C remaining constant, 4 possibilities 0 0 0 1 1 0 and 1 1. Okay. So, for these cases, 4 cases, we see the order of the corresponding pairs where A is changing from 0 to 1. So, A is BC 0 0 is this one. So, the color is matched here. So, these two cases the BC is 0 0. The corresponding value A is 0 here, 1 is A is 1 here. And what is the value of y at that time? Y is remaining 0. So, y is not changing, remaining constant with 0. So, y is 0. So, that way if BC is 0 1, BC is 0 1 over here. So, this will be pairing with this one, and you see that A is changing from 0 to 1. What is happening to y? Y is remaining 0. So, y is remaining 0. So, similarly for next case y is equal to 1, and last one for BC is equal to 1 1, this case, these two rows. So, A is changing from 0 to 1, and at that time y is also changing from 0 to 1. So, y is just following the A. So, at that time we are writing y is equal to A. Is it clear how we are entering a variable? Similarly, we could have entered B, we could have instead of 3 variable, 4 variable and all, the process would have been similar. So, forming a pair and finding a relationship and accordingly coming up with the truth table. Okay. Now, how it is useful in how it can be used in simplification, right, entered variable. So, now entered variable map that we are talking about, in this the variable will be part of the Karnaugh map. Okay. It will be included in the Karnaugh map. So, before that let us look at the normal simple Karnaugh map based simplification that we could have done for the same example. So, this is the example, right, the one that we have taken up, and these are the two groups that is possible, right, and the corresponding product term that is available is BC prime and AB. Now, we can also think of this as BC prime, the product term that is generated multiplied by 1 and ANDed with 1. Okay. Any min term that is there, so the corresponding value ANDed with 1, and if the min term is not present, the corresponding input variable combination ANDed with 0. So, that is why it is 0. So, this is the way also it can be visualized, okay, with no loss of meaning. So, if we look at this way, then it will be clearer how we are getting a SOP entered variable map based simplification. So, the truth table that we had just seen, we are simply mapping it to a that was a 3 variable Karnaugh map. I mean there are 8 locations, 8 cells. Now, since one variable is entered, A and B are the variables against which the map is formed. So, this is a 4 cells are there, and in the cell we will be having entry of 0, 1 and the variable. Okay. So, these are the likely members, variable and its complement form, these are the possible members. Okay. So, for the same problem, the present problem, we have this as the entered variable map. Okay. Now, for the simplification, so we have to form the largest group where all the ones and the variables need to be covered, all the ones and the variable need to be covered. So, what we see over here, so there is a 1, this is the 1. Okay. So, there is no other 1. So, this 1 is covered. Okay. So, this 1 is covered how? This A is there with a value 1 and B is there with a value 1. So, AB is the term, and we consider that it is ANDed with 1. So, AB is one term that will get generated. Okay. Now, we see there is a term C prime, C bar. Okay. Now, this C bar we can take this as A bar, B ANDed with C bar, that is also fine, that is also is Boolean algebra wise, expression wise it is correct, but it is not the minimized expression. So, to get the minimized expression, we can consider this 1 as 1 plus C prime also, right. So, there is a hidden implicit C prime here without any making any difference in the meaning of the entered value. So, this C prime and this C prime, they can be combined together, and for which B is remaining constant with a value B, and the variable that is entering, we are simply ANDing it with the value that is remaining constant, which is B here. So, B C prime is the corresponding term that is getting generated. So, same truth table with entered variable map considering A, we shall see this is the corresponding map, and for minimization, again with 1 we are getting the B and C prime, ANDed with 1, and for A we can consider 1 as 1 plus A, without any difference in meaning, and that will generate B, and entered variable is A. So, AB. So, BC prime AB, here this is the way BC prime and AB, and we get the same expression. Now, we take into note one interesting point here, that the one that we have seen here, which we are writing as 1 plus C prime or 1 plus A to get a minimized expression, the same one can be written as C plus C prime also, right. So, if we have a hypothetical truth table like this, for which the entered variable is what you see, then your this one, the C part can be combined with this, and C prime part can be combined over here, and we do not need a separate coverage of 1, because the components that are making 1, C and C prime, they are individually covered by these two groups, and that will generate you a BC prime plus AC, which is a minimized expression, and no separate coverage of 1 is required. Is it okay? So, that is what we take note of in minimization using entered variable map. The same thing can be used for POS simplification, product of sum simplification, the same truth table. In this previous case, we considered that it is getting, wherever there is a min term present, it is getting ANDed with 1, min term absent means it is the corresponding input combination is getting ANDed with 0. So, that is why it is not there. So, in this case, the sum term whenever it is present, we can consider that it is getting added summed with 0, and if it is not present, then it is getting summed with 1. So, that is the way. So, 1 means just the corresponding max term is not available. So, the corresponding POS simplification. So, again earlier we considered 1 as 1 plus C or 1 plus C prime, right, or C plus C prime. So, this is the way. So, here 0 can be considered as 0 and C prime, 0 and C, or C C prime, and accordingly we can use it for forming a larger group if it is so possible. So, in this case what we see, these zeros can be combined together, these two zeros for which b is remaining constant with a value 0. Okay. So, b remaining constant with a value 0 means b uncomplemented will be coming as the sum term, right, and here the other group that can be formed 0. So, 0 can be considered 0 c prime. So, a is remaining constant with 0. So, that is a prime will be there, okay, and the c prime is already there. So, that is the way you get the corresponding term. So, similarly for the other case. Okay. Now, to end we look at the example with which we started, the 5 variable example. So, the 5 variable example, now we would want one of the variable to be entered. So, we consider the variable e is entering into the map. So, when variable e enters, so then we will be forming pairs the way you have seen. So, these adjacent columns, okay. So, 0 and 1 is changing, the rest of the values are remaining constant a, b, c, d 0 0 0 0, and accordingly the corresponding output how y changes with e, that is mentioned here. So, y is not changing with e for the first case, y is remaining 0, y is just opposite of g, complement, the complement of, so 0 1 1 0. So, this is e bar, and accordingly you have all the positions covered. Okay. So, with that we look at the 5 variable representation of the this truth table that we had just seen, okay, where e is one of the entered variable. So, with e entered variable in the respective places, now the 5 variable now has become a 4 variable problem, okay, which is more convenient. So, this is one of the advantage that it reduces by the number of cells reduces by a factor of 2. I mean it is divided by 2. So, 32 now becomes 16. Okay. So, 16 is a more manageable proposition for variable Karnaugh map. Okay. So, in that case these are the way the variables are entering here, right, and then this is the largest group with e content for which b is remaining constant. So, b ended with e, the variable that has entered. Okay. Then what is remaining to be covered? This e prime and 1 1. Okay. So, this 1 1, okay, can be considered as e plus e prime. So, with that one group can be formed, that is this 1 1 can be considered in this manner, right. So, that is one group, and this e prime will go there, that is another group. That is one possibility. Another is only it can be considered as 1 plus e prime, right. So, each of these cases is considering 4 possible 3 literals in the expression. So, in one case this is b prime, d prime, and d is remaining with 1 and e is remaining with e is the variable that is entering. So, b d e prime. Is it fine? Okay. This is SOP. So, the one that is 0 will be corresponding prime term will be there, right, and one if you consider this particular block. So, this is coming as a and d, right, d is remaining constant, a is remaining constant, and e is the entered variable that will cover, and if these e is not included, only one is considered, then a, b prime and d ended with 1, right. So, this is these two ones can be covered, these two ones can be covered as 1 plus e or e plus this one can be covered as 1 plus e or e plus e prime, right. So, that way you have got two possibilities the way you had seen before. Okay. So, with this we come to the conclusion of today's class, this particular class. So, simplification of 5 variable function using Karnaugh map requires that 3D visualization, whether it is reflection map or overlay by which the adjacency can be found. for the map entered variable, variation of output with respect to the entered variable is considered for cases when other variables of the function is remaining constant. In SOP realization, each one and the entered variable complemented or uncomplemented need to be covered, and POS it is 0 and those entered variables need to be covered. And for EVM entered variable map based SOP minimization, one can be considered as 1 plus the variable 1 plus x prime or x plus x prime, and for POS 0 can be considered as 0 ANDed with x, 0 ANDed with x prime or x prime, by which the minimization can be made more efficient. Thank you.